Hey there. You're here because you want to get smarter, right? More efficiently, and without feeling like you're drowning in a sea of textbooks.
Right, like you just want the real, matey insights, the stuff that really clicks and you can actually use in your busy life.
You've definitely come to the right place for that. Because today we're doing a deep dive into something absolutely fundamental to, well, pretty much everything: sleep.
I mean, we all do it day in and day out.
Or at least we try to.
Yeah, that's true. But the actual science behind it.
Get ready, because it's way more fascinating and, frankly, mind-blowing than you might think.
Totally. And to guide us on this deep dive, we've got Matthew Walker's book, Why We Sleep.
Exactly. And we're going to pull out the most important and honestly surprising takeaways because, and Walker makes this incredibly clear, this isn't just about feeling rested.
Oh, not at all. This is about understanding the very foundation of your health.
Your cognitive abilities, your emotional well-being.
And even our collective well-being as a society.
So let's just jump right into it. Walker lays out a pretty startling reality right off the bat. He says that in developed nations, two-thirds of adults aren't getting the recommended 8 hours of sleep.
Wow.
I mean, does that sound familiar to anyone?
Oh, big time.
Right. It's definitely not news to me. But here's the thing. Walker doesn't stop there. He connects the dots in a very direct way.
How so?
Well, he links consistently short sleep to a significantly shorter lifespan. Like, no mincing words. Less sleep equals less time on this planet. The World Health Organization has even gone so far as to declare a sleep loss epidemic.
A sleep loss epidemic. That's pretty serious.
Seriously is right. And if you think about it, it's not really that surprising. You look at countries like the US, the UK, Japan, South Korea, even Western Europe, all places where we've seen the most dramatic declines in sleep.
And at the same time, they're all wrestling with rising rates of both physical and mental health issues.
Exactly. And that makes you wonder about just how strong that connection really is.
It really does.
And here's the thing. We're not just talking about these long-term health consequences. Let's not forget about the immediate dangers of sleep deprivation. I mean, think about drowsy driving.
Oh, yeah. Scary.
Scary is an understatement. Walker points out that drowsy driving is responsible for more accidents than alcohol and drugs combined.
Really?
Yeah. And just in the US, there's a fatality every hour connected to fatigue-related errors. That's like every time you get behind the wheel after a bad night's sleep, you're taking a huge risk.
Right.
So this all begs the question. If it's not just about recharging our batteries, what exactly is sleep? It seems obvious, but Walker breaks it down into 5 pretty specific characteristics.
Okay, I'm intrigued. Hit me.
All right, so first you've got reduced physical movement. Basically, when we sleep, we're still. Then there's decreased awareness of and reaction to the outside world.
Makes sense. We kind of tune everything out.
Yeah, exactly. Then there's a typical posture most of us tend to take on when we sleep.
Like curled up or on our side.
Yeah, or on our backs. And then there's a lack of communication.
Like we're not chatting it up while we're asleep.
Exactly. Unless you're sleep talking, but that's another story.
Right, right.
But here's the most important part. Reversibility. Meaning that unlike being in a coma, you can be woken up from sleep.
True.
Plus, and I think we can all relate to this, you know you've been asleep because your awareness of your surroundings basically vanishes. It's like lights out, you're gone.
Totally. And there's that weird thing with time, right? Where, like, you close your eyes and suddenly hours have just vanished into thin air.
Like you fall asleep on a plane and have absolutely no clue how long you were out.
Exactly.
Walker even calls it a chronometric void.
I love that.
Me too. It's a good one. Now, when scientists really want to get a handle on what's going on during sleep, they turn to a method called polysomnography.
Polysomnography.
Yeah, or PSG for short. Basically, it's a way to comprehensively track all sorts of things like brainwave activity, eye movements, and muscle activity while someone's sleeping.
So they can really see what's happening under the hood.
Exactly. And it's because of PSG that researchers like Azarinsky and Kleitman made a truly groundbreaking discovery. They found that sleep isn't just this single uniform state. Instead, we cycle between 2 fundamentally different types of sleep: NREM and REM.
NREM and REM.
Yep. NREM stands for non-rapid eye movement sleep, and REM stands for rapid eye movement sleep. This was a total game changer in how we understand sleep.
Oh, like it blew everything wide open.
Totally. So let's break these stages down. Walker uses this really cool analogy to explain brainwave activity, and I think it helps visualize what's going on. Imagine a giant football stadium.
Okay, I'm picturing it.
When you're wide awake, it's like all the individual fans are just chatting away, having their own conversations, kind of doing their own thing. That's similar to your brain cells, each firing off independently, creating all this random activity.
So it's like all this noisy, desynchronized activity.
Exactly. But as you start drifting off to sleep, specifically deep NREM sleep, it's like the entire stadium starts chanting in unison. That slow, synchronized brainwave pattern is the hallmark of slow wave sleep, also known as deep sleep. And within these slow waves, you also got these short bursts of intense activity called sleep spindles.
Sleep spindles, what are those?
They're these little bursts of activity within the deep sleep waves that scientists think are involved in things like memory consolidation.
Interesting.
Yeah, and even in protecting your sleep from being disrupted by outside noises and stuff.
Huh, that makes sense.
So then you've got REM sleep, which is also called paradoxical sleep.
Paradoxical sleep. That sounds interesting.
It is, because this is where things get really weird. See, during REM sleep, your brainwave patterns look almost identical to when you're wide awake. All this fast, desynchronized activity. But here's the catch. Your muscles are basically paralyzed. It's called atonia.
So your brain is all fired up, but your body is totally still.
Yep, that's the paradox. And that temporary paralysis is super important because it prevents us from acting out all those crazy dreams we have.
Like imagine trying to run from a dream monster in real life.
Exactly. Chaos. But get this, certain areas of the brain can actually be up to 30% more active during REM sleep than when you're awake and going about your day. It's kind of wild. Of course, essential functions like breathing keep going smoothly, thankfully.
So we've got a pretty clear picture of what sleep is, but that still leaves the big question. Why do we even need it in the first place?
Right. And one way to look at that is from an evolutionary perspective. Walker points out that NREM sleep is pretty universal across the entire animal kingdom. Pretty much all animals do it. But REM sleep, that's a little different.
In what way?
Well, it's mainly found in birds and mammals, which suggests it's a more recent evolutionary development.
Fascinating. So like maybe NREM serves some more basic function, and REM is something that evolved later for, I don't know, some other specific purpose.
It's a good question. And Walker uses some interesting examples to illustrate the point, like fur seals.
Fur seals, what about them?
Well, when they're on land, they have both NREM and REM sleep. Pretty normal, but when they're in the ocean, their REM sleep basically disappears.
Really?
Yeah, they only get like tiny snippets of it.
Wow. So that really makes you think about just how important each type of sleep might be.
It does, especially since Walker points out that NREM sleep came first, evolutionarily speaking.
Uh-huh.
But then you look at dolphins and whales, and they do this amazing thing called unihemispheric sleep.
Unihemispheric sleep.
It's where only one half of their brain sleeps at a time.
What? How does that even work?
It's pretty incredible. It lets them keep the other half of their brain awake so they can maintain vital functions like coming up to the surface to breathe.
Wow, talk about an adaptation.
Right. And then on the flip side, you've got migratory birds like sparrows who are unbelievably resistant to sleep deprivation during their migrations. It highlights just how adaptable our biological needs can be under certain circumstances.
That's incredible. Like their bodies are basically saying, okay, sleep is important, but right now survival takes priority.
Yeah, exactly. And it makes it clear that there's still a ton that we don't know about sleep and how it works.
Totally. So much to explore.
Absolutely. So let's bring it back to us humans and how our sleep patterns have evolved over time and across cultures. Walker talks about how in pre-industrial societies, a biphasic sleep pattern was the norm.
Biphasic, what does that mean?
Basically, it means having two distinct periods of sleep separated by a period of wakefulness. Think of it like first sleep and second sleep.
Huh. So midnight wasn't always the middle of the night.
Exactly. But now we've shifted to this consolidated sleep schedule, where midnight is often right in the middle of our sleep. And we haven't necessarily made up for that by sleeping later.
Right. Our internal clocks and the demands of modern life don't always line up.
Exactly. It's a recipe for feeling constantly sleep deprived. Plus, we've mostly abandoned the good old afternoon nap, at least in Western cultures.
Which is a shame because those naps can be glorious.
Totally. It's also fascinating how dominant REM sleep is in infants. It takes up a whopping 50% of their total sleep time.
Really? That much?
Yeah. And Walker explains that this is because REM sleep is absolutely essential for early brain development.
In what way?
Well, it helps lay down the massive network of neural connections. Think of it like building the infrastructure of the brain.
Wow. So messing with their REM sleep could have serious consequences.
Absolutely. There have been studies in baby animals where disrupting their REM sleep during this crucial time actually leads to some pretty severe developmental problems.
Yikes. That's kind of scary.
It is. And on that note, there's also this growing understanding of a connection between REM sleep and neurodevelopmental conditions. Like people with autism often show a big deficit in REM sleep, sometimes up to 30 to 50% less than neurotypical people. Huh. Yeah. And researchers are actively trying to figure out if this lack of REM sleep actually contributes to some of the challenges associated with autism.
It's amazing how much we're learning about all this.
Right. And speaking of things that can affect baby sleep, Walker also brings up the impact of alcohol during pregnancy and breastfeeding.
Oh, yeah, that's a big one.
It is. He says it can really suppress REM sleep in both the fetus and the infant. And not just that, it can even mess with their breathing patterns during sleep. He makes it very clear that REM sleep isn't optional in early life, it's a biological necessity.
That's good to know.
For sure. So as we transition from infancy into adulthood, the ratio of NREM and REM sleep gradually shifts.
How so?
By the time we reach our late teens and adulthood, it's more like 80% NREM sleep and 20% REM sleep.
So we get way more deep sleep as adults.
Yeah, exactly. And there's this fascinating theory by Feinberg that suggests the intensity of deep NREM sleep actually goes up and down during adolescence.
And what does that do?
Well, he thinks it might be a key factor in brain maturation, especially in the prefrontal cortex, the part of the brain that handles all that higher-level thinking and decision-making.
So teenagers need all that deep sleep to develop their brains properly.
That's the idea. And then, as we get older, into our golden years, things shift again. Older adults often start going to bed and waking up earlier. Their sleep gets more fragmented with more awakenings throughout the night, and their bodies just produce less melatonin, that sleep-regulating hormone.
Right. Makes sense.
But one of the biggest changes is a pretty substantial drop in both the amount and the quality of deep, slow-wave sleep.
So they just don't get as much of that restorative sleep as they used to.
Exactly. And that can have a big impact on their overall health and well-being.
So is there anything older adults can do to improve their sleep?
Walker mentions a few things, like getting exposure to bright light in the late afternoon can help shift their circadian rhythm a bit later. And in some cases, prescription melatonin, when used properly with a doctor's guidance, can help boost their natural melatonin production and improve their sleep architecture.
That makes sense.
Okay, let's switch gears now and talk about a function of sleep that's hugely important for all of us, no matter what age. Memory. Walker does a deep dive into how sleep helps solidify new memories.
Like, how does that work exactly?
Well, he differentiates between the roles of early night deep NREM sleep, which seems to be crucial for factual memories like names, dates, stuff you learn from a textbook.
Okay, so that's when all the facts get locked in.
Yeah, exactly. And then later in the night during REM sleep, the focus shifts more to emotional memories and learning new skills.
Both physical and mental, right?
Exactly. And the way this works is amazing. There's this back and forth communication between the hippocampus, which is like the brain's short-term memory hub, and the cortex, where long-term memories are stored. And this mainly happens during those deep and REM sleep phases. It's almost like your brain is transferring files overnight.
So that's why pulling an all-nighter before a test is a bad idea.
Totally. And even a short nap during the day that includes some NREM sleep can make a big difference in memory consolidation.
Wow. Naps really are magical.
And here's something even more incredible. Walker talks about how sleep can even rescue memories that we think are lost.
What? Right.
Yeah, like information you thought was gone forever, your brain can potentially retrieve it during sleep.
It's like a recovery service for your memory.
Exactly. And get this, it's not like your brain just randomly strengthens all your memories during sleep. It actually seems to choose which ones to prioritize based on tags or connections that were formed when you first learned the information.
So it's like the more important the information is, the more likely it is to stick around.
That seems to be the idea. And there's this great story Walker shares about a pianist who was really struggling to learn a new piece. He went to bed feeling super frustrated, and then when he woke up, he could play it perfectly.
No way.
Yeah. And research actually backs this up. Sleep really can boost skill learning, even without any extra practice. And there's this time of night effect, specifically for motor skills. The last 2 hours of sleep seem to be the most crucial.
Why is that?
That's when those sleep spindles we talked about earlier are most active, and they seem to be directly involved in solidifying those motor memories.
So if you're trying to master a new sport or a musical instrument, make sure you get those last 2 hours of sleep.
Absolutely. Okay, now let's talk about what happens when we don't get enough sleep.
Uh-oh.
Yeah. It's not good. Walker really drives home the point that consistently getting less than 8 hours of sleep has a huge impact on our physical performance. It can lead to decreased endurance, less power output, and even reduced muscle strength.
So it's not just about feeling tired, it actually affects how your body performs.
Exactly. And then there's this attention test developed by Dinges where he showed a clear decline in cognitive performance as sleep deprivation increased.
Like the more tired you are, the worse you do.
Yep. And when you get to the point of total sleep deprivation, the consequences are pretty catastrophic. It affects pretty much every aspect of how your brain works.
Yikes.
And don't even get me started on the car accident statistics. Walker points out that driving on just 4 hours of sleep or less is about as risky as driving drunk.
Terrifying.
And the risk goes up exponentially with each hour of sleep you lose. He even shares this tragic story about a truck driver who caused a fatal accident after being awake for 34 hours straight.
That's just heartbreaking.
Yeah.
And it really drives home the point that sleep deprivation can have life or death consequences.
It absolutely can. And this is why some aviation authorities are now allowing pilots to take prophylactic or power naps to reduce the risk of fatigue-related errors.
That's a good move.
It is. But even those naps aren't a perfect solution. As Walker points out, there's no magic pill or quick fix that can truly replace a full night of sleep.
Okay, so we've talked about the physical and cognitive effects. What about the emotional impact of sleep deprivation?
That's another area where things can get pretty messy. Basically, when you're sleep deprived, your amygdala, the part of your brain that processes emotions, becomes way more active.
So you're basically walking around on edge all the time.
Pretty much. And at the same time, the prefrontal cortex, which usually helps regulate your emotions, starts to lose its grip.
So you're more reactive, more irritable, less able to handle stress.
Exactly. And Walker also points out a disturbing link between not getting enough sleep during childhood and an increased risk of experimenting with drugs and alcohol earlier in life.
Really? There's a connection there.
Yeah, it seems that way. And if you look at people who are already struggling with psychiatric conditions, you almost always see sleep disturbances as part of the picture. There was even a study in Italy that showed sleep deprivation could actually trigger manic or depressive episodes in people with bipolar disorder.
Wow. That's powerful evidence for the mind-body connection.
It is, and it also emphasizes how important that first night of sleep after learning something new is. Walker says you can't just catch up on sleep later and expect your brain to consolidate those memories in the same way.
So if you stay up all night cramming for an exam, you're actually doing yourself a disservice.
Exactly. And there's more bad news. Researchers are finding a possible connection between disrupted deep sleep and the buildup of amyloid plaques in the brain, which is a hallmark of Alzheimer's disease.
So could lack of sleep actually contribute to Alzheimer's?
It's a scary thought, but some researchers think it might. And then there's the glymphatic system, which is basically your brain's cleaning crew.
The cleaning crew.
Yeah. It gets rid of all the metabolic waste and toxins that build up in your brain, and guess when it's most active?
When we're in deep sleep.
You got it. During deep NREM sleep, it becomes up to 10 times more efficient. So if you're not getting enough deep sleep, all that junk starts to pile up.
It can't be good.
Not good at all. And there's also a link between sleep loss and a higher risk of relapsing after getting sober from addiction.
Why is that?
It seems like it might have something to do with overstimulating the dopamine receptors in your brain's reward pathways.
Wow, the ripple effects of sleep deprivation are pretty far-reaching.
They really are. It's not just one or two things. It affects virtually every system in your body.
Right.
Walker presents a ton of research showing that consistently sleeping less than you need significantly increases your risk of developing all sorts of serious diseases: heart disease, obesity, dementia, type 2 diabetes, even cancer.
So it's not just about feeling tired or sluggish the next day. It's about your long-term health and well-being.
Exactly. And he goes into detail about some of the specific ways sleep deprivation messes with your body. Like, let's talk about the cardiovascular system. Adults over 45 who sleep less than 6 hours a night have a 200% greater risk of having a heart attack or stroke.
A 200% increase. That's huge.
It is, and it seems like the sympathetic nervous system, that fight or flight response, plays a big role. Even something as seemingly minor as daylight saving time has been shown to cause a temporary spike in heart attacks.
Wow, our bodies really don't like having their sleep disrupted.
Nope, they don't. And then there's blood sugar control. When you don't sleep enough, your body becomes less sensitive to insulin, which increases your risk of developing type 2 diabetes.
So sleep deprivation messes with your metabolism too.
Yep, big time. And then there are the hormones. Sleep loss throws a whole bunch of them out of whack. It increases ghrelin, the hormone that makes you feel hungry, and decreases leptin, the hormone that makes you feel full.
So you're basically hungrier all the time.
Exactly. And on top of that, it increases endocannabinoids, which can make you crave unhealthy, highly palatable foods.
Oh no. So you're hungrier and you want junk food.
Pretty much the worst combination. And here's the
Right.
kicker. Studies have shown that you don't actually burn that many extra calories when you're sleep deprived, so all that extra eating goes straight to your waistline.
Double whammy.
Totally. And it's not just the hormones. Your brain activity changes too. When you're tired, the prefrontal cortex, the part responsible for rational thought and decision-making, becomes less active, while the deeper brain regions associated with reward and pleasure get more active.
So you're less able to resist those tempting treats.
Exactly. And it doesn't stop there. Sleep deprivation also messes with your gut microbiome thanks to all that extra cortisol it produces.
The gut microbiome? That's surprising.
I know, right? It affects everything. And you want to hear something even more surprising?
Hit me.
It even affects your reproductive system. Studies have shown that young guys who only sleep 5 hours a night for a week see a significant drop in their testosterone levels.
Wow, okay. So not sleeping enough can literally affect your hormones.
It's crazy, right? And it also weakens your immune system. When you're sleep deprived, your body doesn't respond as well to vaccines, and your natural killer cells, which are crucial for fighting off infections and cancer cells, don't work as effectively.
So you're more susceptible to getting sick.
Exactly. And in the long run, chronic sleep loss can even damage your DNA and shorten your telomeres, which are those protective caps on the ends of your chromosomes that are linked to aging.
Okay, so basically, sleep deprivation is bad news all around.
It pretty much is.
All right, let's move on to something a bit more fun. Dreams.
Yes, dreams. That's where REM sleep really shines. It's when we experience those super vivid, often bizarre dreams. Walker even calls them routinely psychotic because they're often so illogical, intense, and disconnected from reality.
I mean, who hasn't woken up from a dream feeling completely bewildered and disoriented?
Right. And the crazy thing is that brain activity during dreaming is actually pretty intense. The visual and spatial processing areas light up. The motor cortex is active even though your body's paralyzed. The hippocampus, which is involved in memory, is firing away. And the emotional centers, like the amygdala and cingulate cortex, are going strong.
So your brain is working overtime, even though you're asleep.
Exactly. And all this activity is what's led scientists to start taking dreams seriously. We're moving away from Freud's purely psychological interpretations, which were often pretty hard to test and didn't always make consistent sense.
So what are some of the leading theories about why we dream?
Well, one popular one is the emotional processing theory, which suggests that REM sleep helps us process difficult or traumatic memories and strip away some of their emotional intensity. Rosalind Cartwright did a lot of research on this, looking at the content of people's dreams when they were going through tough times.
And what did she find?
She found links between certain dream themes and emotional recovery. And it's interesting because there's a medication called prazosin, which was originally developed for high blood pressure, but it's now being used to treat trauma-related nightmares in people with PTSD.
Really?
Yeah. And it's thought to work because it affects REM sleep.
Wow, that's fascinating. So maybe our dreams are actually helping us heal.
That's the idea. And REM sleep also seems to be crucial for our ability to read facial expressions and understand other people's emotions, which is obviously super important for social interaction.
Makes sense.
Yeah. Studies have shown that sleep deprivation can actually impair that ability. And get this, there's even evidence that dreams can boost creativity.
Oh, yeah, I've heard about that.
Like the story about Mendeleev figuring out the periodic table in a dream, or Keith Richards coming up with the riff for satisfaction while he was asleep.
Pretty cool. But is there any science behind that?
There is. Robert Stickgold did some research showing that during REM sleep, our brains tend to connect seemingly unrelated concepts, which can lead to those aha moments of creative insight.
So our dreams are like brainstorming sessions for our subconscious.
Exactly. And sleep, especially REM sleep, also seems to help us grasp complex grammatical rules and solve problems that require a sudden flash of insight.
Wow. Sleep is basically a superpower for our brains.
It really is. And during dreaming, our brains are also busy integrating new experiences into our existing web of knowledge. This has been shown in studies where people learn virtual mazes.
So our dreams are helping us make sense of the world around us.
It seems that way. Now let's shift gears a bit and talk about what happens when sleep goes wrong.
Sleep disorders.
Right. Walker goes into a few different ones. Somnambulism, which includes sleepwalking and sleep talking, actually happens during deep and REM sleep, not REM sleep like a lot of people think.
Huh.
And then there's insomnia, which is unfortunately super common. Basically, it's when you're chronically dissatisfied with your sleep, either the quantity or quality, and it causes you distress and messes with your ability to function during the day.
So it's not just about having trouble falling asleep every now and then.
No, it's more than that. It has to be going on for at least 3 nights a week for 3 months or longer. And a lot of times, the root of the problem is an overactive sympathetic nervous system. That same fight or flight response we talked about earlier.
So you're basically wired and stressed, even when you're trying to sleep.
Exactly. And then there's narcolepsy, which is a neurological disorder where people experience excessive daytime sleepiness.
So they just can't stay awake.
Pretty much. They often have these sudden attacks of muscle weakness called cataplexy, sleep paralysis, and even hallucinations when they're falling asleep or waking up.
Wow, that sounds really challenging.
It is. And it's caused by a loss of orexin-producing cells in the brain. Orexin is a neurotransmitter that helps regulate wakefulness.
Huh. So without enough orexin, your brain just can't stay awake.
Exactly. And then there's this really scary one called fatal familial insomnia.
Fatal familial insomnia.
Yeah, it's a rare prion disease that basically causes progressive and untreatable insomnia. It's really devastating.
So basically, people with this condition eventually can't sleep at all.
And they sadly don't survive very long without it. And the animal studies on total sleep deprivation are truly disturbing. Rats deprived of all sleep die within a few weeks, experiencing severe physiological distress and a complete shutdown of their immune systems.
That's horrifying.
It really highlights just how vital sleep is for survival.
It does. Okay, so we've covered a lot of ground here. What are some of the key takeaways?
Well, first and foremost, Walker debunks a lot of common myths about sleep. Like, you know that study that's often cited about pre-industrial tribes sleeping only around 6.75 hours a night?
Yeah, I've heard that.
Well, he clarifies that just because people are getting a certain amount of sleep doesn't mean it's enough for them to thrive. He points out that these tribes, even though they're physically active, often have shorter lifespans than people who consistently get more sleep.
So it's not just about what you can get by on, it's about what your body truly needs.
Exactly. And he also talks about how artificial light disrupts our natural sleep-wake cycles. It suppresses melatonin production, which can delay our bedtime. And while lots of people use alcohol to help them sleep, Walker emphasizes that it actually messes with your REM sleep, leading to poorer quality sleep overall.
So, not a good sleep aid after all.
Nope. He also talks about the importance of body temperature for falling asleep. It turns out that losing heat from our hands, feet, and head actually helps us drift off, which is why a cool bedroom is generally better for sleep.
Makes sense.
Yeah. And then there are alarm clocks. Waking up to a jarring alarm before your sleep cycle is finished triggers a stress response in your body. It's like starting your day with a jolt of adrenaline.
Not exactly a recipe for a peaceful morning.
Right. And Walker is really critical of prescription sleeping pills. He says they're not very effective at producing natural restorative sleep, and they can have some pretty nasty side effects.
Like what?
Memory problems, an increased risk of certain cancers, rebound insomnia when you stop taking them, and even dependency.
Yikes.
He's a much bigger fan of cognitive behavioral therapy for insomnia, or CBTI, which addresses the underlying psychological and behavioral stuff that's contributing to insomnia.
So it's more about getting to the root of the problem.
Exactly, and it's been shown to be more effective in the long run without all those nasty side effects.
That's good to know.
He also talks about the relationship between sleep and exercise, pointing out that while exercise is good for sleep, getting enough sleep might be even more important for how well you perform and recover from exercise.
Interesting.
Yeah. And a really crucial point is that sleep debt is cumulative. You can't just skimp on sleep during the week and make up for it on the weekend.
So those all-nighters do catch up with you eventually.
They do. Okay, ready for the really big picture stuff?
Lay it on me.
Walker doesn't stop at individual health. He expands the conversation to talk about the societal implications of our sleep-deprived culture. He points out that insufficient sleep costs businesses a ton of money every year because of decreased productivity, people calling out sick, and more errors.
So it's not just a personal problem, it's an economic one, too.
Exactly. And thankfully,